Hey guys, so let's discuss new round of Microsoft interview loop, which is round 7, and this is cloud and Azure round. Okay, so here the question is given, let's say to you, is your application runs on AKS. AKS is Azure Kubernetes Service. Okay, and traffic suddenly increases 100x times. How would you prepare and respond? So here we will be seeing answer based on three roles: software engineer, senior software engineer, and architect. Okay, so expectation differs by level. So senior software engineer, 2 to 5 years of experience, should understand AKS fundamentals, auto scaling, and caching and monitoring. Okay, and here senior software engineer, 6 to 12 years of experience, he should design scalable cloud native systems with resiliency, observability, and deployment strategy. Okay, if anything fails, resiliency, retry, dead letter queue, all those things, idempotency, observability, okay, monitor logs and everything, and then deployment strategies. Now principal engineer or architect, 12 plus years of experience, so he should be able to design global distributed Azure platform. Okay, means entire globe can use it with multi-region failover. If one region is failing, you should deploy to another region. You should use another region, request should forward it to another region. And cost governance and operational excellence. Okay, operational excellence, continuous delivery of the high quality softwares. Okay, so step 1 is the objective. Okay, the system should handle 100x traffic spikes, then maintain low latency, prevent downtime, scale automatically, protect downstream systems, minimize cloud cost, and recover automatically from failure. The software engineer will answer for this is expected answer: I would first ensure the application can scale horizontally using Kubernetes. Okay, I would enable HPA. HPA is horizontal pod autoscaling in Kubernetes. Okay, cache frequently accessed data with Redis, autoscaling cache. Okay, and then monitor resource utilization. He will do observability thing here and protect the application using rate limiting. Okay, so rate limiter he will use on API gateway level. So the high level architecture will be look like this: user request will go to Azure front door or load balancer, you can say. From there it will go to API gateway, from there AKS cluster. Okay, now in AKS cluster you will have a pod, then Redis, then service bus, okay, for the async communication, and then other services, and then it will, they all will communicate with database. Okay, let's say you have Azure SQL database. Now senior software engineer, 6 to 12 years of experience, should expected to answer that handling 100x traffic increase require scaling every layer, right? Not only pods, you will increase the number of pods. Every layer you required scaling. Every layer means not just Kubernetes pod. I will combine pod auto scaling, then node auto scaling. Okay, servers, caching, asynchronous processing, resilient communication pattern, and comprehensive observability. Every layer you need to scale, so then only you will able to handle 100x traffic. Now resilient communication pattern, what does that mean? Resilient communication pattern are ways for services to communicate reliably even when the services are slow, unavailable, and fail temporarily. Okay, so just introduce queue there and store all the requests in a queue. When the service is when service will recover, it will again read the queue and then will process the remaining request. Okay, this is the concept behind it. So simple example: suppose meeting service needs to send an email. Okay, without resilience, what will happen? Meeting service will send email to notification service, but notification service is down, so in that case meeting creation fail. Okay, but with resilience, what will happen with resilience? So meeting service, you will send the request to messaging queue, but then notification service is down, right? So meeting will get created, email is sent later when notification service recover. Okay, so at least bare minimum thing should work, like meeting user able to create the meeting, notification we will send later. Okay, once the this service recover, then it will read from the queue and then will send it. Okay, now common resilient communication pattern if you talk about, so retry, circuit breaker, timeout, messaging queue, fallback, and bulkhead. Okay, so retry means try the request again if it fails temporarily. Circuit breaker, stop sending requests to a failing service for a while. Timeout, don't wait forever, fail quickly if a service doesn't respond. Okay, messaging queue, store request and process them later. And fallback, return a default response if the main service is unavailable. Bulkhead means isolate failures, so one service doesn't bring down another service. Okay, so production architecture, if you see, so user request will go to this load balancer, okay, Azure CloudFront, which is handling your global entry point and routing thing he will do. Then API management, like your API gateway, security, throttling or policies will be here. Okay, and then you will have a AKS clusters. Okay, not only one AKS cluster, means you have multiple AKS clusters here. Okay, so in which you will have different services running in a pod. Okay, and pod is running in a node. So and then you will have a Redis service bus and event hub, and after that it will go and store that into data into database and blob storage. Okay, if you require to save files or documents, okay, and or media files. And then you will have a monitoring also, observability, okay, which will monitor your application insights, and Azure monitor will be using here. So what is the design goal for the architect here is elastic scaling. Okay, then high availability, fault tolerance, low latency, cost optimization, and zero downtime. Now principal engineer, or sorry, this one was for a senior software engineer. Now principal engineer or architect, 12 plus years of experience, he would be expected to answer, I would design the platform for elasticity from day one. Okay, it's not like you have completed the development, now it is in production, now do the infrastructure thing and all those things. No, it should be he should introduce elasticity from day one only. Okay, every layer, including networking, compute, messaging, caching, storage, databases, okay, must scale independently. The platform should support multi-region deployment, automated recovery, and policy-driven cost optimization. So this is the architecture. Global user, okay, from entire globe, anybody can use your application. So it will go to Azure front door, which is nothing but global entry point, traffic routing, firewall security, okay, web application firewall, DDoS protection, all those things are here. Then you will have a regional API gateway, multiple gateway for particular region API gateway, and then you will have a AKS clusters, okay, multiple region, multiple clusters, and then same the application services, okay, then Redis and Azure service bus, event hub. Okay, we will see why we are using event hub here. So basically it will store this user clickable event, and which has the millions of events are getting generated, right? User has clicked it, user then went to this page and that page. These are events. So we store these events in a event bus so that the downstream system or secondary system then can process those events. And then observability, okay, same your Cosmos DB as Azure SQL, or blob storage and Azure monitoring. That's similar to the earlier image. Now guiding principle will be here, horizontal scalability, active deployment, okay, active passive we have already talked about, fault tolerance, observability, cost governance, and then automated recovery. So active deployment means you have multiple region, you have deployed your application in multiple region, and multiple regions are active. Request can go to any region and you will get the response. Active passive is you have deployed to 2 region, but at a time only one is available, and if it will goes down, then we will forward request to another region. Okay, so that is the active passive. Now let's talk about follow-up question here. So first one is horizontal pod autoscaling, HPA. Okay, so software engineer will say about HPA is, HPA automatically decreases the number of pods based on metrics such as CPU, memory, and custom application metrics. Okay, senior software engineer will say that use custom metrics like request per second, then queue length, okay, and response latency. So instead of relying on CPU, so here he is saying that use the queue length. Let's say I have some queue, okay, and it has some capacity. Once the capacity is about to complete, okay, then do auto scaling. Okay, so based on that response latency also, and then request per second. Principal architect will say use stabilization windows or scale policies. What is that? Wait for traffic to remain consistently high or low before scaling. So pod don't keep increasing, decreasing every few seconds. Okay, wait for some time. Follow-up question 2 is related to cluster autoscaling. So software engineer will say that if the cluster doesn't have enough capacity for new pod, the cluster autoscaling automatically adds a worker node, right? Pods are running in a on a nodes. Now your node doesn't have capacity to add new pod, so you will add new node itself, and then there you will create a pod. Because a senior software engineer will say that the flow will be something like this: you need a more pod needed. Okay, so in that case, no available node, there is no space available on node, then cluster autoscaler, what it will do, it will create new VM node, and then a pod scheduler will create a pod there. So principal architect will say that use multiple node pools. Okay, now what is multiple node pools? Create separate group of servers like nodes, okay, for different type of applications such as general purpose application, then memory intensive application, GPU based workloads. So you will create different nodes, and then you will create a pod on that nodes. Scale them independently, increase or decrease only the required node pool based on demand, improving performance and reducing cost. Okay, follow-up question 3 is related to database bottleneck. Okay, so how you will reduce database bottleneck. So software engineer will say that reduce database load by introducing Redis caching. Okay, just use a cache. Senior software engineer will say that additionally strategies is read replicas. Okay, create a read replica and then write. So you can read from multiple replicas, and write will happen in one database only. Then connection pooling. What is connection pooling? Connection pooling is technique where an application create fixed number of reusable database connection instead of opening and closing a new connection for every request. You're sending request to database, that time it will not open and close connection. It has already some connections open in fixed pool. Okay, connection pool, it will take from there and again put it there, the connection. So this overhead you don't need to do, boilerplate code and all. Now query optimization and database indexing. So this is how he will handle the database bottlenecks. A principal architect will say that separate read and write workloads. Okay, this is what senior software engineer said about the read replicas. Partition large data set and use asynchronous processing wherever the strong consistency is not required. Okay, eventual consistency. Now follow-up question 4 is related to Redis. So what software engineer will say that you should cache the user session and frequently accessed data in cache. Senior software engineers say that also cache your API response, configuration and authentication tokens. Okay, principal architect will say that implement multi-level caching. So he will be talking about multi-level caching. So application, okay, user application processed by the application, user request processed by the application, let's say. So then you will have a local cache. Okay, application first check the local in memory cache. If it is there, then it will take the data from there. Otherwise it will go to Azure cache for Redis, which is the distributed one. Okay, then if it is still not there, then database. So use appropriate eviction policies and TTL. Okay, so wherever you are using cache, you need to keep in mind that you have to use proper eviction policies and TTL. And now the fifth one, last one, is Azure Service Bus. Okay, so Azure Service Bus is, a software engineer will say that Azure Service Bus enable asynchronous communication between services. Senior software engineer will say that use for order processing, email notification and background jobs. Okay, so Azure Bus you will use for all these tasks. Principal architect will say support retries, date later queue, duplicate detection and transactional messaging to improve reliability. You will use Azure Bus for these things. Okay, you will use these things. Now for this follow-up question 6, this is the last one, Event Hub. I was talking about this one, right? So software engineer will say that use Event Hub for high volume event ingestion. High volume event ingestion means, see, senior software engineer say it is designed to handle millions of events per second. Okay, millions of events per second, making it idle for application that continuously generate large amount of data, such as clickstream event. Clickstream event means wherever you are clicking, it is storing that event somewhere in Event Hub. Application telemetry. Okay, applications performance data and all. IoT device data, Internet of Things device data, and log ingestion. Event Hub provides scalable, reliable event ingestion so downstream system can process the data effectively. So what is the clickstream events? Data that records every user action on a website or app, such as page view, clicks, searches, purchases. Okay, application telemetry is performance and health data collected from an application, such as response time, CPU usage, error, request, and memory usage. Now, easy example is click stream example. What you will take, like user opened the home page, let's say, okay, and he clicked book meeting, then he selected date and confirm booking. So these are the events. Application telemetry example, like API response time is 120 milliseconds, CPU is 65% used, error rate is 0.2%. Okay, so principal architect will say about event hub is partition event hub effectively to maximize throughput and scale consumer independently. Okay, so this is your event hub. Partition it so that multiple consumer now can read it, okay, independently. So that's it. Thank you.